I've been using the terms propositional logic and truth functional logic interchangeably in these lectures because this kind of logic goes by both terms. People use either one or both of those terms. They use propositional logic because the fundamental unit of consideration in this logic is the proposition of the sentence. And then other folks like to use the term truth functional logic because we realize that when we're evaluating propositions or when we're evaluating statements, we recognize that the truth value of the entire compound statement is really just a function of its parts. Okay, and what I mean by that is this. Given a statement like this, A dot B, we recognize this is a compound proposition comprised of the simple statements A and B, and the statements are being joined together by the conjunctive dot, and we know that the truth value of the dot is going to indicate the truth value of the entire statement. Okay, so if we know the truth value of A and B, we could deduce the truth value of the dot. So if somebody tells us, oh, you know what, A is true and B is true, great. Well, now I can consult my handy guide to conjunction and look at each of the 4 lines to see what the value of the dot is when what appears on the left-hand side of the dot is true and what appears on the right-hand side of the dot is true. And I see in that circumstance, the dot itself is true. So we were able to determine the truth value of the entire statement simply by consulting the component parts with known truth values and then making deductions. And we can do this with increasingly complex statements and eventually arguments, as long as we take a very careful, methodical approach to our deduction. And what I mean by that is this, is we want to make sure that we always know what's the main operator, what's the main operator's truth value going to be determined by, and what are the steps that I have to take and in what order to get to that ultimate goal of identifying the truth value of the main operator. So you take a statement like this, tilde A dot tilde B. We know here that the main operator of this statement is dot because it's the only operator other than tilde outside of brackets and parentheses. So whatever the truth value of the component parts are going to determine the truth value of the dot. And we're being told here that A and B are both true. But unlike the previous statement, we can't use the truth values of A and B to immediately determine the truth value of the dot because A and B are both being operated on in this statement. They're both preceded by tildes. And it's going to be those tildes that allow us to determine the truth value of the dot. The truth values of the tildes are going to determine the truth value of the dot. Now we know that tilde operates on whatever it appears next to, and so here we're going to be able to use the rule of negation to figure out what the truth value of tilde is. We know here on line 1 of our negation chart that when a given proposition is identified as true, its negation is false. So what that means is if A is true, tilde A is false. If B is true, tilde B is false. And now I don't even have to worry about the truth values of A and B anymore. Okay, because the component parts that are relevant to me now when I want to determine the truth value of the dot are the truth values of my tildes. Okay, and if I pull up my chart showing all of the features of conjunction, I see right here on line 4, when what appears on each side of the dot is false, the dot itself is false. Okay, so we had to go in this very particular order from A and B's known truth values to tilde A and B having known truth values to them being able to arrive at the truth value of the dot. A statement like this, tilde parentheses A dot B parentheses. We're always going to want to make sure we know what it is that we're looking for here, and it's going to be the truth value of the main operator, which is the operator outside of parentheses, which in this case is tilde. Tilde is the only operator outside of parentheses. Okay, and we're being told once again A and B are true. I'm always going to start by working inside parentheses. And if A and B are true, my guide to conjunction tells me, yes, dot is also true, but remember tilde doesn't distribute. Okay, so when I'm trying to figure out the truth value of tilde, I am not concerned with the truth values of A and B. All the truth values of A and B tell me are what the truth value of the dot is. And because tilde operates on what it appears next to, the tilde here is going to operate on this dot. Tilde appears next to these parentheses. So tilde doesn't operate on A, doesn't operate on B, it operates on the dot. And so I know that whatever the truth value of the dot is, in this case true, the truth value of the tilde is going to be the exact opposite. So knowing A and B are true allowed me to deduce the truth values of the other component parts of the statement, ultimately arriving at the truth value of the main operator, the tilde.